Welcome back. This is part 2 of the continuity algebra stuff. What I'd like to do now is I'd like to go through another instance where you are going to have to use continuity. And what that is it's a situation where you have piecewise functions and there are some extra things missing in them. And then you have to say where those things will be, what the value of the missing pieces will have to be in order for them to be continuous. So what I want to show you is I'm going to present my screen, and let's get this to show, and I'm going to write out a problem for you, okay? So this is what the problem looks like. So we're going to go with f of x equals, and it is a piecewise function, x squared plus b squared for any values of x less than 2. And then we also have bx plus 2b for any values of x greater than or equal to 2. So here's the thing. This is a piecewise function. We know that at 2, we are going to have some sort of issue. That is why these are our restrictions. So both of those functions below 2 are going to have to be, continuous functions. After 2, it's going to have to be a continuous function. But what happens at 2, we need them to be the same. Okay? We want it to be continuous all the way through. Okay? So there's some things we have to kind of consider. So if we want this to be continuous all the way through, what that means is the limit as x approaches 2 of the function from the left has to equal the limit as x approaches 2 from the right, which is the function on the bottom. So the key thing here is those two limits have to be equal. If they're the same value going from left to right, then that means that they are going to be continuous also, okay? So when doing this problem, you set both of the chunks equal to each other. Once they're equal to each other, now we have to do direct substitution, and let's try to figure this out. So let's substitute 2 in for all of the x's. And then we have b times 2 plus 2b. So notice what happened when we substituted that in. We now have an equation that is going to probably be a quadratic, okay? So the x's are gone, and we're trying to calculate what that b is. So we want to figure out what the value of b is. So this is going to be 4 plus b squared equals 2b plus 2b. So let's just keep doing the math. Equals 4b. So we have 4 plus b squared equals 4b. Now, you need to remember, when you're going to solve quadratics, you have to get everything on one side and get it equal to 0. So let's rearrange all of these terms. I'm going to move the 4 over here, so it becomes negative 4b. I'm going to add 4, and I'm going to make it equal to 0. If you have a quadratic, your brain should automatically think all the time that it is going to be factoring of some sort. So let's factor this and figure out what are our values of b that are going to work. So if I factor b, and then I need to get positive 4. So the numbers that give me positive 4 are, let me circle it in red. Numbers that gives me positive 4 are positive 2 and positive 2, or negative 2 and negative 2. Remember, the ones you pick have to add up to the middle number. So I know it's going to be negative 2 and negative 2, and that has to be equal to 0. So what value of b will give us 0? Well, b minus 2 equals 0, and b minus 2 equals 0. So the number is b equals positive 2. So what letter for b will give you a continuous function? Well, that function has to look like this. What it is x squared plus 2 squared, whatever the value of b is, and then down here it's going to be 2 times x plus 2 times 2. So this would now be a continuous function because we basically set it up that the limit from the left equals the limit from the right, and the value of b will be positive 2. Okay? Now, I'm also going to show you one more problem. It's a very similar type problem, except this one is going to be calculator driven. Okay? So we're going to do a similar problem, but this time we're going to use much more complicated equations. So with this problem, I'm going to give you f of x, and it's going to equal some really weird things. Now, this is one of those problems, I will tell you, that on the AP Calc test, they allow you to use a calculator. So what I'm trying to do is show you how to use your calculator to solve a problem that is a little more complex. Okay? And this is for x less than or equal to 1, and this is for x greater than 1. So we now have this function. Okay? Anytime you have a function or something like this, they're going to ask you, what value of c will make it continuous? What value of c will make this continuous? Okay? Well, if it's going to be continuous, that means the limit from the left has to equal the limit from the right, also has to equal the value. Well, this is less than or equal to, so we're going to have a value. Now, we also know one other thing. The place that the problem is going to occur is if we're going to have a discontinuity, it's going to be at x equals 1. So let's go through and let's think about what this is. So I'm going to take the limit as x approaches 1 from the negative side, which is 2 minus the sine of x, has to equal the limit as x approaches 1 from the right side, which is this c times x times the square root of x squared plus 2 plus c. Okay? So this is what we have. Now remember, you always need to do direct substitution to start. And what that's going to do is that's going to kind of simplify some of our stuff. So let's do some direct substitution. And this is going to be the sine of 1. Okay? And then we have to plug 1 in for all the x's. So that's going to be c times 1 times the square root of 1 plus 2 plus c. Now, let's do some simplification or a little bit more. This can't be simplified anymore, but this side can. We don't need to say times 1, and then 1 squared plus 1 squared is 1 plus 2 is 3. So we have 3, the square root of 3 times c plus c. Okay? Now, the reason that this one is going to be a little more difficult to solve is because of these two sort of equation things right here. There's no factoring, there's no other ways of solving it. So there is a calculator way that you can do this, okay? And what I want to do is I want to show you how to do this on your calculator. If these are going to be equal, I want you to think of this as two just separate equations. So on our calculator, we're going to set y1 equal to this. Oops, I made a mistake there. That should be 2 minus the sine of 1. And then on our calculator, we're going to make this equal to y2 on the calculator itself. So let's go to y1, and I'll clear what I have there. And I'm going to make y1 equal to 2 minus sine, and notice that it is of 1. Okay? So that's going to be some sort of constant line at a really weird spot. There's no variable. I'm also going to make now equation 2 this side. But instead of using c, I have to use what the calculator's used to. The calculator's used to that being x. So I'm going to say x, and then I'm going to put the square root of 3, and then I'm going to say plus x. Okay? And I am going to graph both of these things. Oops, I forgot to close that in. So make sure you close your parentheses there. And now we're going to graph it. Now you'll notice my graph's a little off. So what I want to do is let's go to Zoom, and let's just go to a standard window. So let's go to Zoom Standard, and let's get those two lines kind of drawn in there. Now, here's what you want to do. You'll notice that there's two lines, and those two lines are crossing at a spot. So we have this line going right here, which is the sine of x1. We have this line kind of coming down here. What we want to do is we want to find out where those intersect. Okay? Now, there are some math things that you can do. So let's go to calculate. On our graphing calculators, you'll notice in the blue up here, it says calculate. So we're going to do second calculate. And what I want to do is I want to find the value where these things are intersecting. Okay? So let's mark the lines. So the first one we want to have, notice the blinking dot. So you can kind of see I can move the blinking dot. There it is. We want to mark it that our first curve is y1 and go. And now the second curve, you'll notice, is y2, which is that equation, and we go. And now that you've marked both of them, you now need to guess. Okay? So the place where these two lines intersect, you'll notice on here, right here in the bottom, is it gives us x is 0.424, and the y value is 1.158. Okay? Most likely what they're going to ask you is they're going to ask you what is the value of x. Because remember, in this equation, we replace the c with x's. So our answer here is c equals 0.424. Okay? So this problem, what it does is it shares with you how to use your graphing calculators to find a place where two of those things intersect. Okay, now that's only if you have a graphing calculator. The previous problem, of course, you had to do some other mathematical things.